All right, folks. I'm working through a wireless sensor network simulation for one of my classes. This is due in about a little less than a month, and got a lot to do. So the first thing that I need to do is okay. Let's run this first. Explain what's going on here. So this is our root node for our network, and what I just added is these red lines that visualize the actual packet route for everything. It's good for analysis purposes, and what I want to do next is, well, for one, I had started on a implementation of this from scratch, but it kind of there's too much overhead, and based on the deadlines, I need to go with what was given to us instead of trying to refactor. That was unfortunately kind of a waste of time, but I think this is pretty sick. I'm proud of this one. This will be cool. You see the entire routing scheme. It's so rad. So yeah, this is obviously tree routing. What we want to add next is show the packets being sent over the network. Done. Create packets in the way of customization. Yeah, let's delete this. We want one. Mesh routing. This will include, what will this include? A neighbor table share to immediate neighbors. Test with peer-to-peer data TX. So let's bring up paint document. What we're going to be doing, if this is a node, and then we have these two here. What's happening? Oh, it's just the final. It's the final setup. That's so cool. I love that. Alright, anyways. If we have these nodes, let's call it 1, 2, 3, 4. So if we have 3, forget about 2 for now. If we have 3 linked to these two, 3 will send out a table share. 2, what will send out a table share to its immediate neighbors. So it'll send 1 to 4 and 1 to 1. Now what this will include is the neighbors that are n number of hops away, depending on what we want to route. For the sake of this, I think we'll just do n equals 1. And let's say 1 receives this. 1 receives from, so 1, 4 is 3's neighbor. I'm getting better with paint. Wow. Okay. 4 is 3's neighbor. Because we have 3 sending this, what 1 will do, 1 will append 4 equals neighbor, and it's a neighbor that is 3's. Oh, it's the hop count 4 will be equals 3 hop count. CNT plus N, where N is this N. And then our how we need to set it up is that we now need a next hop in order to get to this node. So what we'll end up doing is, let me turn music down a smidge. Okay. Next hop is going to be what is next hop going to be? Oh, our next hop is going to be 3, because 3 is how we get from here to here. I think that all makes sense. So let's start implementing it. So we have this send table share. What we want to do is for a nhop mesh routing scheme, share the neighbors of a node that are n hops away. So we'll add a config parameter called mesh hop max equals 1. So what we will do is for networks in self.neighbors table, for now let's just print this because I don't know what's in here. We will not do that. We will not do that. We will not send this yet. Okay. We call send table share timer table share timer table. We want to see this get entered. Print table share. Okay. Timer table. Oh, so we never set it. Okay. So we want to set it when after a node becomes registered. And what's our table share interval? We should make this like, you know what? Let's see it. Okay. We want to set the timer table share when we become a self.set role registered. Once we become registered, we want to start doing this, because then we know we'll actually have neighbors. Okay. Okay. We don't have network update as an on receive yet, right? Ooh, we do. Okay. So we need to change that name to where is it? Table share. We might want to route this. I think we do want to route that. Route and forward package. I hate Python tabbing so much. Alright, cool. So we will do self.route and forward package. And this is our package. Alright. We will send this only to immediate neighbors, because then it will extend by 1. So we will want to add to this logic if neighbor returning values. So this is a dictionary. If neighbor of hop count equals config dot, where's the config file? How are we referencing it? Just like that. Okay. Where were we? Config dot, what was it? Mesh hop max. Mesh hop n. Actually, I like that more. Then we will pretty much, if this is true, we will collect list of these hop count neighbors and send to all neighbors. Actually, no, we will send this to all immediate neighbors only. Because after this, we will have, because once this is in place, we will have neighbors that are more than 1 hop away. And if we keep doing that, we might end up with a cycle. So at least to start, this keeps it pretty safe. I want to add to the register roles.registered. This goes for any role except if you're you are a, I think just an unregistered node is the only one that you would maybe not want to do this with. But if, let's just put a placeholder for now. If packet type equals not network update, this is table share. If neighbor in table share data is not our neighbor, append to neighbor table with hop count plus 1. Hop count plus 1? Yes. Next hop equals sender of source address of message. Okay. And then for now we'll just break. Continue? What? Pass. Same with, what do I call it? What's the sensor data one? Turn sensor data, sensor data. Okay, let's find every instance of sensor. Timer sensor. That's right, okay. We implemented this. Actually, it doesn't hurt to keep it there for right now. Okay. And we know that the type should be sensor data. Okay, cool. And then we want this. I guess we only want this if it's, we don't really care for root in doing this. We just want nodes to do it. Undiscovered, we don't want to do anything with it. Let's add it here. Dude, I swear. Okay. We have this. And then if we are unregistered, we don't want to do anything with that. And then data. No, the data comes second. Let's get the routing done. Okay. So what are we trying to get when we run this? We want to see what is in our neighbors table. Yes, these are the two things we want. So let's see it. Okay. Oh, this is growing very fast. Okay. Oh, these are all... I'm logging every message? Okay. Hop count is 3. We should have logged it. Self.log. Okay. What's this? That's it? Okay. Then what's wrong with our prints? Something is... That's it? We're printing the packets. That was dumb. We should not have been doing that. Alright. Let's see this now. Okay. That's so cool. Okay. Hang on. Hang on. So we have node. I can't see anything. We gotta wait till the network converges. Oh. We only have heartbeat messages, but we have our hop count. But is this hop count true? Let me see. So for node 19, where's 19? 19's right there. We have our unique ID as 18, which is that one. Which is one hop away. Yes. We have 28, which is how is 28 2 hops away? It heard a heartbeat, but it's not connected. Oh wow. Okay. Alright, let's go. Alright, let's Jeez Louise. Hang on. Why are hop counts growing so much? My days. This is impossible to keep a hold of. These hop counts are huge. Alright. I'm not really sure what's going on there. Okay. It just doesn't make sense to me that a node would have neighbors that's registered with only hop counts greater than 1. Okay. Oh. What are these being sent? Oh, wait. Okay. Alright. Let's stop. I just want to see what's going on. Okay. So this is a great example. Node 91. Node 91 only has... Where are you, 91? Where's 81? So I guess that's close. Where's this node? 89. 83, 90... Okay, maybe 91's not the best, because I think it's covered in this image. 90. 90's... I saw 90. There's 90. Okay. 90 has... So hop count... Ooh. hop count is your hop to the root. Okay. Okay, let's think about this. Let's open up a scratch pad. Hop count currently stored as the number of hops to the root node. We want a hop count that is distance from neighbor. So this will have to be separate. I think we'll just call this neighbor hop count, I guess. I'm trying to think if there's a better way to do it. Well, I don't think there is. Because as of right now, all our neighbors are immediate hops. But that's soon to change. Okay. So, how do we implement this neighbor hop count into our packets? Let's go see where hop count is added. PCK hop count. Where do we draw up that packet? Go for the root. This is hard. Give me 1 second. Alright, we're back. Let's come back to it. Okay. So our hop count is our distance from root. So what we need to do is for every heartbeat that we hear, we need to add if we hear a heartbeat, we need an update neighbor. Where's update neighbor? There it is. Okay. Candidate parents table. Let me go to chat. I need to see how I can add key to this. Oh, I can just do it. PCK of neighbor hop count. Let's think about this. Equals 1. We're doing it on heartbeat, registered, heartbeat, heartbeat. We're only doing it on heartbeats. So, okay. Yes. Not packet structure. We add this to the heartbeat response as those are our closest neighbors. But does that mean we're linked to them? They're in our vicinity, so they're one hop away. That's the whole point of meshing. Yeah. Okay. Alright. So now if we log these messages, I'm hoping to also see a neighbor hop count in these that are equal to 1. Hop count is 0. Neighbor hop count is 1. Neighbor hop count always 1. Cool. Cool. So, while this is running, where am I? Okay. Send table share. We'll keep that, but if neighbor okay, if neighbor of neighbor hop count is equal to our mesh, then we want a list of these. So we'll have, how do they do it? Okay. Mesh neighbors equals this. We will, what's append versus extend? Okay. Adds a single item to the end of the list. Extend adds multiple items from an iterable. Okay. Then we just want append. We want to append zneighbor. And then we want to send neighbors, where neighbors is our mesh neighbors. Okay. And to start, we're sending this only to immediate neighbors. But our destination is not this. Our destination... So we'll increment over this again. Why does it do that? Okay, cool. Here, we will send for neighbors. For neighbor in neighbors table dot values, we will send self dot neighbor we don't want channel address. We want... Okay, chill. We saw enough. Neighbor hops are 1. Huge. It's all coming together. We don't want our cluster head address. We just want... I guess we just want the source. Dest is neighbor. Yeah, okay, we got it. Neighbor of we don't care about distance. Yeah, it'll just be source. Source will be that address, and then neighbors. Okay. Let's print, or let's self.log the mesh neighbors. Cool. All right. Let's run it and see. That is sick. We can color code them too. Color code different types of messages. Table share equals purple, for example. Okay. Things still happening here? Yes. That is sick. Okay. So we just want to make sure that doesn't crash. But it looks like we're chill. Let's look. I can't right click copy? It's weird. Anyways. So we will send this table share out to our neighbors. Upon receiving, if self dot roll does not equal root roles dot root, then for neighbor in PCK of did I just call it neighbors? Yeah. for neighbor in our neighbors. We know what our neighbor table will look like. If neighbor let's figure this out. Hang on. Please say that didn't exit. Called neighbors. And I do for neighbor in PCK or in neighbors. How would I select that key value from neighbor? Self dot neighbor table wait, why isn't hang on. Self dot neighbors table dot keys oh. Not in with the same effect. Okay, that is probably easier to read for everyone. That is sick. That is sick. Okay. Alright, cool. So we can do... Where'd my logic go? Oh, here it is. If neighbor not in self.neighbors table, append to dictionary. Self.neighbors table. Well, first of all, let's do packet I have a packet dictionary, but want to increment one item in it and change oh, I can totally do that. I'm stupid. Packet of neighbor hop count plus equals 1 and our packet. Is it guaranteed to have a next hop? It's not, but we'll add it. Next hop equals packet Alright, this gotta stop. I can't read anything. Alright. So a register, we don't have a cluster address. Makes sense. Our neighbor hop count is 1. We need the source. Neighbor tables. Cool. And then let's self.log self.neighbors table. And the logic is going to be the exact same in our register. Rolled will never equal root when we're just registered. What is it, shift tab? Yeah. Cool. These will be the same, so just go for it. List object has no, let's see. Oh, it's a list. Why did I make it a list? items, we'll have neighbor, comma, packet again. We will have this. This is our neighbor. Packets. I'm at the point where neighbor looks weird. Alright, let's... Whoa! Alright. Oh! This is gonna break. Packet. Neighbor hop count equals 4. Why is that happening? How is the neighbor? Hang on. I can't read this at all. Hop count equals 2. Hop count equals 8. Neighbor hop count equals 3. How is that happening? Mesh neighbors of neighbor, and then we send this. If neighbor not in self.neighbors table. What's our table share logic? I'm so confused. Okay. Seems like there's a lot of table sharing going on. Let's if packet neighbor hop count equals our config mesh hop n, then we add that. What I don't understand Alright, we only have neighbor hop count equals 1. Okay. Like, let's take this one for example. Node 97. It printed it all on one line. 97. Next hop 8695. Dude. Okay, wait. Okay. I think that was a good time to grab that. This is not the one we want anymore. This is. Okay. So, what node? Node 97. Okay. Where's 97? 97's here. We're saying 85 is 2 hops away. Okay, I can see that. I can see that. So let's go to another. Let's go to another. Neighbor hop count equals 4. How are we getting this? This part I don't understand. How do we... Okay. Next hop is 86 cluster head. Source is... oh yeah. Let me think about this. So for node 97 has 88 in its neighbor table. Its neighbor hop count's 1. It has 98. Its neighbor hop count is also 1. Neighbor hop count equals 1. Neighbor hop count equals 5. For what node? 78? $97. And our what's our next hop? 78. 78's cluster head? Oh yeah, it is. It's blue. Okay. Next hop is itself. Wait. Neighbor hop count from what node? Man, I gotta like pause the music or something to think through this. Neighbor hop count. Is that the, so is that what happens with... Okay, neighbor hop count equals 2. 99. Where's 99? There you are. So we do not have next hop being done correctly. Next hop for mesh is not done correctly. It's currently the node in question. Okay. Okay. PCK source. Duh. That's the packet we're feeding in. Packet neighbor hop count. Equals PCK. Do we even want the packet or do we want... No, we don't want the whole table share. PCK of... let me think. We want the neighbor hop count in that packet. So we will do... Do we want plus equals 1? Hang on. We have our packet that has our tables. We don't have that neighbor. We plus equal that neighbor hop count. I think that makes sense. Let's do this again. We can also add if packet of neighbor hop count is greater than 2. How do we throw an error? How do we throw an error in Python? Okay. All right. I'm going to run this and I'll be right back. I'll be right back now. My mic's gonna die soon. Okay. All right. Let's go back. All right. What went wrong? So first off, okay. This is from node 69. I can't tell which one 69 is. I can't tell what any of these nodes are, actually. Okay, so we have 68. We at least know that's 78. So our next top is 68, 78. I can't tell. Let's run it again. Let's run it again. If config dot viz. Let's toggle it this way. I'm so confused. I just set viz to 0. It takes in config, right? It doesn't. From how do we install it here? I guess. Let's see if that works. That's so weird. Anyways. There we are. Should happen very soon. There we are. So, my guess... Okay, let's look. Node 78. Alright. Okay. So for this is node 78. We see 79. 1, 2, 3. 1, 2, 3. Oh wait, the next hop. Wait, the next hop is 79. And this for 69? No, that's a one. That's a single hop. What's going wrong? How would it grow? We need to look at what we're sending here. Let's first do that. Because I can't really read what's going on here. Okay. This should... What I'm not expecting to see is a mesh neighbor table. Whoa, what just... That was so weird. Okay, something went wrong. Makes sense. We have our mesh neighbors. We shouldn't see a single one with a hop count greater than 1. We do not. However, you get here, then we have this. Hop count equals 2, neighbor hop count equals 3. Oh. Oh, no. Okay, these are 2. So that one's updated correctly. But then... So let's look at these. So 67. 57. 56. And 46 has one of 3. Okay. Okay. So, if packet type So I guess we self.log neighbor hops, self.log packet of neighbor hop count. Whoa. And then we want to log the packet itself. Okay. $52 is sending mesh neighbors with a neighbor hop count of 2. Let's look at this. I need like a Google Doc. Because it's not printing correctly into the text file. Okay. That's a lot. Let's segment by there, 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 and there. I think that's everything separated out. Seems like it. Let's look at this. So node 42 is sending out this mesh. We have 33. Neighbor hop count is 1. Makes sense. 52, neighbor hop count is 1. 62, neighbor hop count is 2. Makes sense. And 42. Okay. Node 62 has this. Oh, I'm not showing you guys. Sorry. So the thing that catches my eye is this node. This node is self-reporting itself as a neighbor, right? That's sketch. So, sorry, I'm getting a text. Alright. What am I doing? Oh, we're debugging. Okay. So we have node 62, and sure enough, it has itself as one of these. So, okay. I'm thinking if neighbor is not in self.neighbors table and neighbor does not equal self dot ID. I think that might be the fix. Let's look. Alright, let's look again. Let's do a new tab. Alright. Node 80. I see 81. Okay. So which one has issues? 92. Okay. Let's highlight that. And we see it here with wait, let me think. So we have this. And is that true? 80 is 2 away from 92? Yep. And then 92 here for 71. It is, but it shouldn't be getting that info. How is it receiving that info? Hang on. Let's look. So in table share, we have our neighbor hops, do the count, and for the given packet, which is what we have. What ends up happening here how is it sending that out? That's the part I don't understand. Oh. Wait. Neighbor hop count. Oh, they already had it. So this is part I don't understand. We send out mesh neighbors. And then we get this. I don't understand. How is what we're sending out any hop count greater than let's look at this. Okay. I don't understand why it's... How are neighbor hop counts incrementing by more? Upon receiving this, well, wait, where are we adding packet neighbor count? We're making a dictionary of those. So, how is this happening? I guess there's nothing else other than let's log the whole packet. I don't think this is that necessary, but self.log the neighbors table, self.log the packet. Okay. Hello. Whoa. Okay. Let's pull this up. Oh gosh, this is so much data. Alright. Well, first things first, we see this, which is an issue. Okay. This oh, there's the difference. Okay. Okay. So we have wait. Oh. We have this being sent from node 68. Okay. have that in here? Where are we at? Oh yeah, we do. So what's our node that's fucked up? 78. Let's find 78 in here. Okay. So we have this. Then we have this. So that's coming from node 69. And then here's this from that node. Hang on. So 78, I heard this from 60, okay, yes. We heard this from 68 as well. So I think what's happening I think the packet is being modified in place. So we need to make a copy. Okay. Let's make CPY equals packet dot copy CPY. So now we're making a copy of it so we don't modify the original. Let's see what happens. Well, there we go. I didn't know that would modify the packet, but I guess it's still in the sending space. So I guess it's not that crazy. Okay, what went wrong? Okay. Before we do anything, okay, let's try this again. is a lot of messages going. Cool. Alright, let's get rid of some log messages. Yeah, I don't want this. All because we were modifying in place. Where's the table share? Oh, we also have print statements. There it is. I just don't want to see any breaks, but I don't think there will be any now that we're making a copy. Okay. And then I also want to see it with the visualization. So we have the data structure in place, which is huge. That's where I wanted to get to. What's it doing as far as like who it's sending to? I kind of forgot about that part. For everyone in the neighbor table. So we'll have to route. Right? Because, yeah. Okay. But. That is really cool. Oh my gosh. Here, let's add to the viz. Let's add to the viz. Where does this stuff exist? Isn't it like in there it is. We want R and B. Packet, we want mesh. I'll just call it mesh. If PCK of type equals table share, then we will do that. Let's make this a function. Line equals line arc. Okay, let's try it again. Let's close this. That was weird. So I want the packets to be red, the mesh ones to be purple. Yes. Sick. This is good work today. So sick. Yes. Sick. All right. All right. Let's call it there. Let's just get out of everything. Commit -m mesh data added and visualization. Cool. Well, I think I'm gonna end the stream there. Obviously, pretty big milestone. The mesh one hop got extended, and we're able to start building out the logic to route multiple hops, and we're now able to visualize those mesh packets versus tree routing packets. So pretty huge. Pretty huge. And I guess it's table sharing packets, but you're sending to your neighbors, so it's the same difference. All right.